Welcome to Uncommon DevOps Wisdom by Uncommon Sense Consulting. Welcome to an insightful journey into the realm of Docker, a containerization platform that is revolutionizing the world of software development and IT operations. Docker, in essence, is a tool that packages, provisions, and runs applications inside isolated environments known as containers. These containers are lightweight, portable, and provide everything an application needs to run, ensuring consistency across all stages of the development lifecycle. Docker has been widely adopted by the tech industry, and its importance cannot be understated. From small startups to tech giants, Docker is reshaping how we build, ship, and run applications. It's helping us break away from the constraints of traditional infrastructure, enabling more efficient use of resources and accelerating the pace of innovation. As we delve deeper into the world of Docker, you'll see why it's becoming indispensable in the rapidly evolving tech landscape. First off, Docker shines brightly when it comes to application deployment. This powerful containerization platform simplifies and streamlines the process, making it a breeze to deploy your applications across various environments. Imagine you're deploying a web application. Without Docker, you might face numerous challenges, like ensuring the right dependencies are installed or dealing with discrepancies between development and production environments. But with Docker, these challenges become a thing of the past. Docker allows you to package your web application along with all its necessary dependencies into a neat, self-contained unit called a container. This container can be effortlessly moved and deployed across a wide range of environments, ensuring that your application works consistently, regardless of where it is run. So, whether you're deploying a simple blog or a complex e-commerce site, Docker ensures that your application deployment is smooth and hassle-free. With Docker, you can ensure seamless deployment of applications across various environments. Next, let's talk about Docker's role in microservices architecture. Microservices have taken the software development world by storm, providing a structure where applications are divided into smaller, independent services. Each of these services runs a unique process and communicates via a well-defined lightweight mechanism, such as a HTTP REST API. Now, where does Docker fit into this picture? Quite simply, Docker provides the perfect environment for developing and managing these microservices. With Docker, each microservice can be containerized, encapsulating it in a neat, self-sufficient package. This package contains everything the microservice needs to run: code, runtime, system tools, libraries, and settings. But Docker's role doesn't stop there. One of the key principles of microservices is the ability to independently deploy and scale each service. Docker's containers make this a breeze. They isolate each service, ensuring that the operation of one doesn't interfere with the others. In essence, Docker is a game changer when it comes to managing microservices efficiently. Let's move on to how Docker integrates with continuous integration and continuous delivery pipelines. Docker is a game changer in this realm, as it integrates smoothly with various CI/CD tools. Whether it's Jenkins, Travis CI, or Circle CI, Docker can work seamlessly with these platforms to automate the building, testing, and deployment of your applications. But what truly sets Docker apart is its ability to ensure consistency across different environments. With Docker, you create a container that contains your application along with all the dependencies it requires. This container can then be moved from a developer's workstation to a testing environment and eventually to production. The result? No more "it works on my machine" issues. This container is a self-sufficient unit, ensuring that your application behaves the same way, regardless of where it's deployed. In essence, Docker has made it possible to automate the software delivery process with unprecedented consistency. Now we're going to discuss how Docker can be used to create reproducible and isolated development environments. Imagine a scenario where two developers are working on the same project on two different machines. One developer is using a Windows machine, the other is on a Mac. Both developers need to ensure that their code runs smoothly, not just on their machines, but across all environments. This can be quite a challenge, right? Enter Docker. Docker allows developers to create what we call containers. These containers hold everything that a software application needs to run, including libraries, system tools, code, and runtime. It's like a mini operating system for each application. So how does this help with creating isolated development environments? Well, once the Docker container for an application is created, it can run on any machine that has Docker installed. The container encapsulates the application and its environment. This means that it doesn't matter if you're running a Windows machine, a Mac, or even a Linux machine, the Docker container will run the application in the exact same way. Now let's talk about the benefits of this. When developers use Docker to create their development environments, they can work in the exact same environment as the production setup. This means that they can code and test in an environment that's a mirror image of the production environment. So, what's the big deal about this? Well, it eliminates a common problem in software development, the "it works on my machine" problem. This is when code works on one developer's machine, but fails when it's moved to another machine, or the production environment. With Docker, you can replicate your production environment, making sure that if it works in the Docker container, it will work in production. With Docker, you can replicate your production environment and eliminate the "it works on my machine" problem. Let's explore Docker's role in facilitating easy and quick scaling of applications. Docker's container-based architecture provides an ideal environment for scaling applications rapidly. This is because each Docker container runs an instance of the application, which can be replicated at will. This means that if your application suddenly experiences a surge in user traffic, you can simply spin up more Docker containers to handle the increase. Now let's talk about handling traffic spikes. Docker containers can be set up with load balancers to distribute incoming traffic evenly across all running instances of an application. This helps to prevent any single instance from becoming overwhelmed, which can lead to slow performance or even crashes. In addition, Docker containers can be easily taken down when the traffic subsides, saving resources and maintaining efficiency. In a nutshell, Docker empowers developers to scale applications rapidly and handle traffic spikes with ease. Lastly, Docker containers can be used to manage application configurations efficiently. These configurations, as you may know, are essential for the smooth functioning of applications across different environments. Docker containers come to the rescue here, offering a simplified yet effective way to handle this task. Each Docker container includes the application and all its dependencies, creating an isolated environment. This means the behavior of the application remains consistent, whether it's being run on a developer's laptop or a production server. More importantly, Docker automates the deployment of these configurations. So whether you're pushing an update or scaling up operations, the configurations remain consistent. This is crucial to avoid the infamous "it works on my machine" problem. In the world of software development, consistency is not just a luxury but a necessity. With Docker, you're not just managing configurations, you're ensuring that your application behaves predictably and reliably across different stages of development. Docker ensures consistency in configurations, simplifying management and reducing errors. In conclusion, Docker's flexibility and power make it a game changer in modern software engineering. Throughout our exploration, we've seen Docker's versatility in action, from streamlining application deployment to empowering microservices architecture. From integrating flawlessly with CI/CD pipelines to creating reproducible and isolated development environments. Docker has shown its mettle in managing rapid application scaling and simplifying configuration management. Each of these aspects underscores Docker's transformative role in the realm of software development and IT operations. But this is just scratching the surface. There's a whole world of Docker applications waiting for you to discover and exploit to optimize your workflows. So, whether you're a seasoned professional or just starting your journey, we encourage you to delve deeper into Docker. Embrace the power of containerization and let it revolutionize your approach to software engineering. We invite you to share your experiences or ask questions about Docker. Remember, Docker isn't just a tool, it's the future of software development and IT operations.